Last episode, we gave our agent one job: explore an unfamiliar project and write its README file. It got there, but it cost 37 tool calls. 20 of those calls, more than half, were the agent just fighting to write one file. Why? Because we gave it just one tool: bash, a shell. Great for running commands, the wrong tool for writing a file. So here's the question this whole episode is about. What happens if we give it tools built for the job? Quick orientation. This is a 6-part series, and we build a coding agent across all of it, adding a single idea per episode. Episode 1 built the loop, and that part is done. This is episode 2, tools. We build the essential set of tools every coding agent needs, then put them to work on that same task from last episode. And these tools stay essential. As our agent grows more capable through the rest of the series, it keeps building on this same set. So in this episode, our loop stays the same, but now we give our agent better tools. Let's get started. One thing to get straight as we learn about tools. The model, an LLM, can only generate text. That's it. Given a task, it can only plan what it should do next, but it cannot itself act on it. It can't touch a file, run a command, query a database, or fetch a web page. It knows what it wants to do. It just has no way to do any of it. So we hand it a set of tools built to do those things. Now instead of wishing, it picks one and asks for it by name. That's a tool call, a structured request, nothing more. So here's the flow. The model picks a tool and the arguments to call it with. Our code takes that call and runs the real function behind it. The function runs and returns its output. And that result gets sent back to the model. Then it decides what to do next. Now let's see how we define a tool. Here's the write tool. It's just a function. It takes a path and some content, writes the file, and returns a confirmation string. That's it, plain Python. Now we need to tell the model about this capability. The model needs a structured definition for the tool, a name, a description, what arguments it accepts. This schema is what the model actually reads. Here's a question you might have. Why do we need this schema and this structure? Why not just hand the model the whole function? Fair question. Let's go back to our write tool. The function here is short, but tools can get lengthy, even hundreds of lines of code, so we would bloat the context. The model only needs to know what the tool is for, what it takes, and what it returns. A schema covers exactly that, and nothing more. But there is still one nagging thing about schemas. Writing that schema by hand for every tool gets repetitive and laborious. Imagine doing this for 10 or 20 tools. So we add a helpful utility to make our job easier, a tool decorator. Here's how it works. You give it a description string, it reads the function's signature, and attaches the schema right onto the function. If that feels like a lot, don't worry. We will go through all of it in the code shortly. The main thing to remember is the why. Each tool needs a schema, but we don't want to manually write it, so we use the tool decorator to help write it for us. One last thing, so our agent can actually use these tools. A few simple lists, a list of the tools, a list of tool names, one for the tool definitions. That's what we pass to the model. Let's see how the agent uses it. When the agent is given a task, it sends it to the model, along with the tools it can use. The model replies with the tool calls it wants to make. For each one, the agent looks up the function by name, runs it, and appends the result back to the conversation. And this repeats until there are no more tool calls. So that's the whole implementation. Function definition, schema decorator, tool lists, and tool dispatch. Okay, before we get into our code, the main question: which tools do we give to our coding agent? In episode 1, our agent had just one tool, bash. This episode, we add 5 more, and each one earns its place. First, list files. Remember how the agent was reaching for ls and find, commands that don't work on Windows? This is the cross-platform fix. One reliable way to see every file. Second, read. The agent can use this tool to pull up any file's contents with line numbers. Third tool we are adding, grep. Useful to search the whole code base for a pattern. Next, the write tool. Now the agent can create or overwrite a file in one shot. The fix for last episode's writing struggles. And the final tool for this episode, edit. Use this tool to change one part of a file without rewriting the whole thing. 6 tools. That's the agent's entire action space. Now let's head over to our code repo. We are back in the code. One quick reminder, here's the GitHub repo URL for this video series. Clone it so you can follow along. The code for each episode lives under the episodes folder. And the one we are interested in, episode 2, tools. There's a new file in here, tools.py. It's a fair bit of code. First, let's hide the comments and doc strings to cut the noise. Next, open the outline panel so we can navigate easily. And close the Explorer to make room for us. This gives you a good view of file contents. Let's bring up our build map for tools. We will start with function definitions first. You can see the 6 tools are here. We have already seen bash in episode 1. Now we will look at 2 of the new tools, list files and write. Let's start with write because we were just looking at it. Here we have it. You have seen this one already, so we won't explain it again. But there's one line worth stopping on. Save path. Every write starts by running the path through it. Let's go and see what it does. The whole purpose of this function is to keep the writes contained in our sandbox folder. See this line? If the path tried to escape the sandbox, this line raises an error. So we don't allow our agent to write any files outside the sandbox. And this safe path check is not just for write. We do the same in other tools as well. Next, let's check the list files tool. This tool's job is to return the list of files given a path. It starts the same way, safe path again, so you can only list what's inside the sandbox. After that, it just walks the folder tree at the given path and collects every file it finds, skipping caches and version control folders. But note this, we are capping the list at 200 files. Why? If a repo has thousands of files, dumping names of all of them would bloat that context for almost no benefit. So the cap on files returned is a way to manage context. Let's step back a second and think about context and tool safety. So far, we've seen 3 of the tools. We saw bash in episode 1. It runs a real shell, so it's not sandboxed, and we flagged the risk there. But it still caps its output at 20,000 characters. Write and list files both stay in the sandbox, and list files caps what it returns too. The other 3 tools round out the set. We won't go through them, but all 3 are sandboxed. Edit only touches what you pointed at, so there's nothing to cap. Read hands back just the slice you ask for. Grep caps its matches and trims long lines. So 2 habits run through all our tools. First, keep the agent sandboxed. And second, keep what it returns lean. Okay, that's the tools themselves. Now let's check the tool decorator that generates the schemas. This decorator is boilerplate code, so don't worry too much if it looks a bit obscure. Typically, you can just copy-paste it from one agent project to another. At the top, it takes the plain English description we want to give the model, and it holds the mapping from Python types to schema types. Then it reads the function's signature, the argument names and their types, and turns them into the list of parameters. And then it assembles the whole thing into the form the model expects, the name, the description, and the parameters, automatically straight from the function. And notice this line. It attaches all of that onto the function itself as a tool definition attribute. Make a note of it. We'll come back to it in a moment. So that's it for our decorator. And now all we need to do is put it on top of our tool signatures. For example, take this bash tool. This line here takes care of the schema generation for us. No handwriting of schemas needed anymore. Our tools are now set up, along with their schemas. Next, we just need to bring information of these tools and their schemas to our agent. For that, we need a tool registry. And that's at the bottom of this script. It's nothing complicated, just 3 small lists. A list for the tools themselves, one to use for the lookup from a tool's name to its function, and one with the tool definitions, the schemas. Remember that tool definition attribute we flagged back on the decorator? Here's where it gets used. We pull it off every tool to build this list. So this list, tool defs, is what we hand the model, so it knows exactly what it's allowed to call and how to use it. Now head over to agent.py, where we have the agent loop. First, let me bring back the Explorer pane and open the agent file. Hide the Explorer again to make room. Now let's check what's changed here. Right at the top, we make the imports from the tools script we just saw. Our next change is in the agent loop, so let's head down there. And scroll down a bit. This part here, every time around, we send the whole conversation to the model, and along with it, the tools. That's tool defs, the list we just saw. When the model asks to use a tool, we read out the arguments it wants, parsing them right here. And this is the one real change from episode 1. We look the tool up by name and call it with those arguments. Then the result goes straight back into the conversation and the loop runs again. So those are the updates. Not a lot of change here. Now let's test this out. We will rerun the episode 1 task, but now with our agent having better tools. Before we run it, let's remember what we're asking the agent to do. It's the same task as episode 1. Explore the target repo, mark down to HTML, and write a README for it. Now with better tools, let's see how our agent performs on the task. Let's bring back the Explorer. Okay, get our terminal up. Same command as before, just pointing to episode 2 code. And run it. Okay, our agent is going at it. This runs for a little while, so let's skip ahead to the end. And it's done. Here are the stats, 20 tool calls. Now remember in episode 1, the very same task took 37 tool calls. We have reduced it down to 20. Next, let's close the terminal and check the README it created. Head over to the sandbox folder. And here's the README it wrote. We asked the agent to cover how to install it, how to use it, its architecture, and how to run the tests. We can see the sections in the outline panel. They are all here. Let's look at a couple of them. Here's the architecture section, nicely written and accurate to the code. And the test section is correct too. Overall, this README is comprehensive and correct. So the agent did its task. Now let's check the stats. 20 tool calls, 9 round trips to the model, and a little under 132,000 tokens in. Here's every call it made. List the files, then read, read, read across the project. Then one write at the end. Notice these are all the new tools we added in this episode. The agent never once used the bash tool this time. Let's color them by what they were doing. And stack them up. Most of it, 19 calls out of 20, was just reading the code. And then one call to write the file. Now remember what we got back in episode 1. The very same task on the very same project, the agent used 20 calls just for writing. And now we have just 1. So that's the effect of good tools on our agent. We have made our agent more capable, safer, and leaner. We took the loop from episode 1 and gave it a real set of tools. List files, read, write, and the rest. And it paid off by reducing the number of tool calls and tokens used. But look at the numbers from that run one more time, especially the tokens used. That's still a lot of tokens, and that's what we get charged for. And that was for an easy task. Write a README. But real work is harder than that. Reading, writing, and planning across a lot of files, over a lot of calls. So that token usage, it only climbs. So before we take on the harder tasks, the loop needs one more thing. A way to manage its own context. That will be our focus in the next 2 episodes, starting with compaction in episode 3. I'll see you there.